You've watched a toddler try to fit a square block into a round hole for what feels like an eternity. You've watched them get frustrated, throw the block, and try again anyway. It's slow, it's messy, it's supposed to be that way, because that's how learning works. But somewhere in a lab in Oxford, a bird solved a tool problem that stumps most toddlers, on the first try, in under a minute. And the real answer for how is far stranger than birds are just smart. Start with what you think intelligence looks like. You probably picture a big brain, a long childhood, years of trial and error before anything useful clicks. That's the human model, and it's the model most people apply to every other species by default. But that model breaks completely the moment you look at a crow. In 2002, a researcher named Alex Katzelnik, working at Oxford, was running experiments with a new Caledonian crow named Betty. The task was simple. A small bucket of food sat at the bottom of a tube, out of reach. Betty had a straight piece of wire. No hook, no tool ready-made for the job. What happened next wasn't in the plan. Betty picked up the wire, wedged one end against the tape holding it to the table, and bent it into a hook. Then she used that hook to fish the bucket out. She had never seen a hook before. She had never been trained to make one. She built a tool to solve a problem she had only just encountered. Compare that to a toddler. A 2-year-old faced with a similar out-of-reach problem will usually try grabbing, then whining, then maybe handing the tube to an adult. Actual tool modification, bending an object into a new shape specifically designed to solve the problem, usually doesn't show up reliably in human children until somewhere around age 5. That's a 3-year gap in favor of the bird. So why does this happen? Why would a brain the size of a walnut outperform a human child on a task like this? The answer isn't that crows are simply smarter in some general sense. It's that crow intelligence and human intelligence were built by evolution to solve completely different problems, on completely different timelines. Human children are born almost helpless, with brains that take over a decade to fully develop, because humans evolved to rely on culture, language, and long-term social learning. You're not built to solve problems alone at age 2. You're built to absorb an enormous amount of information slowly, from parents, from other children, from an entire society around you. Your intelligence pays off over decades, not minutes. Corvids don't have that luxury. New Caledonian crows live in environments where finding embedded insect larvae, food that's physically difficult to extract, can mean the difference between survival and starvation. There's no multi-year apprenticeship for that. A researcher named Nicola Clayton at Cambridge has spent decades studying corvid cognition, and her work suggests something important. Corvid brains evolved what's sometimes called physical cognition, a kind of intelligence specialized almost entirely around understanding cause and effect in the physical world. Bend this, and it becomes a hook. Drop this, and the water rises. Corvids in her studies have solved Aesop's Fable-style tasks, dropping stones into a tube of water to raise the water level high enough to reach a floating piece of food, understanding the relationship between object, volume, and outcome without ever being taught it directly. Here's the part that reframes everything. A toddler isn't behind because they're less intelligent. A toddler is behind because human intelligence isn't optimized for fast physical problem solving in the first place. It's optimized for something almost invisible in a simple lab test: social learning, imagination, and language. A developmental psychologist named Alison Gopnik has spent years arguing that the long, seemingly inefficient childhood humans go through isn't a design flaw. It's the entire point. Children are built to explore widely and inefficiently, testing far more possibilities than a specialized problem solver ever would, because that wide exploration is what eventually produces flexible, general intelligence, the kind that lets a human adult build a bridge, write a symphony, or teach a machine to think. A crow gets a fast, narrow win. A human child is quietly building something much bigger and slower underneath the surface. So when you watch a crow bend a wire into a hook in under a minute, you're not watching a genius. You're watching an extremely specialized tool, millions of years in the making, aimed at one very specific kind of problem. And when you watch a toddler fumble with a wire and give up, you're not watching a failure. You're watching the early, awkward stages of the most general-purpose intelligence on the planet, one that trades speed now for enormous flexibility later. This distinction matters more than it seems. It's easy to rank intelligence on a single scale: smarter, dumber, better, worse, and assume whoever solves the puzzle fastest wins. But intelligence isn't one thing. It's a set of trade-offs, shaped entirely by what kind of problems a species actually needs to solve, and on what timeline. A crow that could think in decades instead of minutes wouldn't survive its first breeding season. A human who could only solve narrow physical puzzles instantly, but couldn't cooperate, imagine, or plan across years, would never have built anything past a hut. You do this same kind of misjudging constantly, and not just with birds. You watch someone solve a problem instantly and assume they're simply smarter than you. You watch someone else take a long, meandering path to an answer, and assume they're behind. But speed and depth aren't the same axis. Some intelligence is built for the sprint. Some is built for everything that happens after the sprint is over. There's something almost humbling in watching a crow outperform a human child at a task and realizing it doesn't actually tell you what you think it tells you. It doesn't mean birds are secretly smarter than people. It means intelligence was never one ladder with a single top rung. It's a branching set of solutions, each one shaped by exactly what an animal or a child actually needs to survive its own particular world. So next time you see a toddler struggling with a puzzle, a bird would solve instantly. Don't read it as falling behind. Read it as the opening chapter of the slowest, strangest, and by far most powerful tool the animal kingdom has ever built. A tool that doesn't just solve the puzzle in front of it. Eventually, it builds the tube, the bucket, and the whole room the puzzle sat in.